Hey everybody, sorry about the delay. We had a bit of a problem with a mouse and a reboot required, plus a little bit more smacking around with the mouse. Still don't know quite what was going on, but my mouse wouldn't allow me to click. So without clicking, you can't do much with the online live stream software. So this is Prospector Jess, huntingforgold.com, sourdoughminer.com. Check out those sites. There's blog posts there that you can take a look at on gold prospecting and finding more gold, introduction to gold prospecting, as well as some tips and tricks for some of you more seasoned prospectors. So I am here to kind of discuss tonight Ridgecrest Quake and Gold Part 2. Hey, this is Prospector Jess. I interrupted this replay of this program because an event happened last night at 8:19 p.m. We had a 7.1, what was really kind of an aftershock, but since it's bigger than the main shock, it now becomes the main shock. So this is a 7.1 update, and it relates to what we're talking about tonight. And the reason is that, I don't know whether you knew it last night, but at about 4 in the morning, there was another nice little jolt. Some of us in this area felt it. I was up and about for other reasons, but it could have been because of that. I just don't know. So you know how those things wake you up and you just don't know if they don't continue. You can't quite put 2 and 2 together. That's the way quakes are. So one of the things that I wanted to go over was the fact that 5.4 this morning was kind of the typical pattern for a quake this big, and that is you will get a big jolt, and then that releases energy in two forms, kind of an acoustic signature, which goes out as a big reflection, and that's the thing that makes the shear waves, which go, shear, and the pressure waves, which basically cause the rocks to compress. Those are basically acoustic waves that travel at the speed of sound in rock, which is really, really fast, much faster than the speed of sound in air. Okay, so what happens is that stuff travels, in seconds, can travel a very long distance, but beyond that, there's also some other energy that's displaced, and that's the actual displacement energy. We used to call it F equals kx, which the k stands for the spring constant of a material, or the stiffness, and the x is how much it's displaced. So if you take a bar of steel and you bend it, and it's spring steel, it will bend to a certain point before it becomes permanently deformed, and if you let go, it'll rebound. That rebound energy is similar to what happens here, and that is when there's displacement and faults, bang, the two of them collide or they rub against each other and stuff bends. You wouldn't believe it, but rocks bend or they compress. And so when they do, they store energy in the form of a spring. That's what gets released when a quake fires up. Basically, it hits the shear strength of that material and pop, things crack. Or the tensile strength, depending upon whether it's pressure or shear, forces. Shear is a sideways force, pressure is, head on, either pressure or tension, So what you're looking at in this case is a mixture of the two, and that's what that whole basketball or what do they call it, a beach ball diagram shows, is where those stresses are oriented, and that can tell you where the fault slipped, and they have a pretty good idea now. I'll show you that in a second because I got a good picture of kind of what's going on, and that is the fault slipped in such a way that there really were kind of two sets of faults that moved in this thing, which is kind of unusual, but it does happen. We had that happen in the 1994 quake in Northridge. When you release that energy and you start tensioning those other springs, some of them are too weak. They're already energized enough and they will give way. When that happens, you get aftershocks. Well, this puppy's had a lot of aftershocks. Let me show you some graphic pictures of that. See if I can get to it. See if my... Oh, yeah, and tonight's sponsored by Government Gold Maps. Check it out. That's how I made those maps last night, and that's how you can make maps anywhere you want to that the USGS has information on it. It's an inexpensive report. Check it out. It's basically, the service is free, but what I show you is how to use the service to get the certain kind of maps that you want to look for when you're prospecting for gold or platinum or diamonds or you name it. Okay, so that's described in the report. So let's take a look at this thing right now. I'm trying to get to the right picture here, and for some reason I'm not getting it. Oh, I know why. Hang on one second here. That is weird. What did I do with that thing? There it is. So this is the series of quakes shown in a graphic picture. I posted this on the page. You can look around and expand it if you want to on the Facebook fan page there. But the basic principle here is it's showing an image of the faulting starting with the first break, which was right here. That big, huge circle. That was the 6.4 that broke loose yesterday morning. Another one broke loose a little further north this morning. It's not shown on this diagram, but it was right about in this region right here. But you can see a whole series of these things. And what's interesting with them, I want to draw in another color here. Let me draw it in blue. And that is, you can see there's obviously a trend in this direction. And then there's a trend in this direction. Okay? And so what ends up happening here is, what does that mean? Are there two sets of faults? And the answer is probably, or more. And so what ends up happening is when one of these things ruptures, they call it a fault rupture, it starts to crack along a line. The line will follow the general fault trend on that fault. But other faults in the area will feel the stress, that tension or pressure or the shear, and they will tend to crack as well. And when they start breaking loose, you start asking yourself questions of where in the world is this headed to? Okay. Well, what I've noted here is the Garlock fault zone. Okay, that's this blue line I'm drawing right through here. Okay, and so what's happening is this thing's heading down toward the Garlock fault on this leg, this lower leg here, right here. And so the question becomes, okay, is it moving very rapidly in that direction, and has it built up any stress down here on the Garlock fault? Because if it has, that's a serious issue. Because when we go about 75 miles in this direction, you're going to smack right into the San Andreas. But, oh, by the way, you're going to go right through Kern County, through the rest of Kern County pretty much, and past Bakersfield, a much higher population area than Ridgecrest, and a bunch of oil wells and mines and various water things and farms and you name it. It's the southern end of the Central Valley in California. Well, that means a disaster, much bigger than this. And if it smacks into the San Andreas and releases it in a similar fashion, then bang, bang. And that's why the USGS and several other people are hinting that, well, this could be, it might be. Frankly, they don't know. But the reality is, it's always a possibility that this thing acts like a fuse and detonates a whole series of things. That would be unprecedented for this region historically. It doesn't usually work that way. One quake causing this to happen within even months or even a decade. Usually it takes many, many years for something like this, but it will tend to propagate along those fault lines. That's part of why the faults are the way they are. They form scarps because they don't get eroded down. And so if you look closely at this picture, let me wipe this out, you'll see this set of hills right through here. Okay, the El Paso Mountains. And on the bottom side of that is this Garlock Fault. Okay, it's swinging right through this area. Now, it's kind of buried in this area out here, but even there, I've driven along this on a couple of geology field trips. It was a nauseating experience. Because the fault has been so active over the years, even with the roads they built, they buckled enough that you can actually, I mean, it feels terrible. It's like a roller coaster. And so, that's just the kind of thing that happens with one of these, and you just have to be aware of it, that those displacements take place, and they can or cannot propagate based on the stresses that build up along the fault line. I just want to touch on that from last night because it wasn't clear, and I didn't get a chance to show you this great picture that's developing. I also found a really cool app. That one of the things that failed here in Southern California was they have a new warning system that's supposed to page you. Well, it didn't fire. And it was determined that it probably should have, and I do understand why it didn't fire. It didn't fire because the quake itself was not large enough, and models they have showed that it wouldn't cause significant damage on this end. Now, that's all fine if the models are good. If the models are kind of marginal, and you were in a big tower that was on some alluvial material, and started to liquefact because of the shaking motion. This particular quake gave a lot of waves. They all of a sudden decided they needed to kind of tune up the sensitivity on this thing. So they turn their detector up a little higher. It'll fire off an alarm when something like this happens next time. That's the nature of science. You know, it's an experimental thing. You try something, it doesn't work quite so well, then you try something new. People want it to be perfect. That's a mistake. Science is really humans making hypotheses and then setting out to test them and prove them. And until that proof works, you know, you'll never, and even if it does, you'll never get 100% perfect results. It just doesn't happen. You want, you know, if you get, you know, a really high factor of result quality, then you're doing really well, and that's considered proof, and could even be turned into a law if enough people can prove it using their own experimental setups, and maybe some that are similar to yours using the same principles. That's when laws become laws. Otherwise, you know, the law of gravity is just a hypothesis, even if the apple hits you in the head. So that's what I wanted to touch on today. It just hit me that we talked about these quakes and that kind of thing. Here's that app I was telling you about. It's pretty cool. It's called Earthquake Alert. I got this one off of Google, the Googles, and you know, pretty much what it does is give you a good idea of what's out there, and it also will give you those kinds of alerts that we're talking about. And so it quickly showed, and it has really cool features that allow you to see how many earthquakes showed up, when, and where. And you can pick on, you know, like one dot here, and it shows you there are 11 earthquakes in this section, the biggest of which was a magnitude 5.4 at 4:07 a.m. this morning. So that's where that red dot is, okay? And so that's kind of a cool tool. It's called Earthquake Alert, exclamation point. My wife pointed it out to me yesterday because she was getting feed from it all day long. She was kind of chiming in. You know, it has other stuff like some stats and things like that. It gives you a bunch of information about the area. So that's the most significant earthquake of the day, which happens to be that earthquake at Searles Valley for the area I have selected, which is a 1,000-mile radius around us here. And that's a pretty useful thing to be able to do, is dial in where you're interested in. I tend to be interested in worldwide quakes, but tend to be interested in ones that are 6 and above when they're worldwide, because there's just so many happen every day. That's something else you want to do, is if you get one of these apps, turn it on and look at magnitude 1.5 and up for the whole world. It'll swamp your computer in a hurry. So I'm a quake nut. Okay, that's it. Quake and gold. So that's kind of it. I just wanted to give you a chance. Don't forget to check out the government gold maps, and this gold ore is the kind of thing that this quake would help deposit. And what we're looking at is quakes and gold and how that interaction deposits gold. Somebody asked me on the site and on one of the video replays from yesterday that, you know, is this the kind of thing that deposits gold, or we're watching gold in action? Yes. It is the kind of thing, and in two ways. One, it fractures the material and allows the hydrothermal stuff to be injected into it. Two, it causes those pulses of energy we were talking about, the pressure waves. When they're in pressure, they go one way. That would cause the water to actually saturate, but it would be under such pressure and temperature that it would stay saturated and wouldn't necessarily deposit any gold. When it expands, goes under negative pressure, also known as vacuum. When that rock expands for the temperature that fluid's at, it can flash into steam immediately. And the minute that happens, boom, the gold starts to crystallize out. Even if it gets at just an instant of that, those little seed crystals are enough for the gold to start forming in a matter of, you know, hours. And so what's going to happen here is it's going to quickly start the process of plating out that gold in some corner right near where the gold was, where that flash happened. And so that's kind of one of the thoughts they have about how gold ends up in these little pockets, is that flashing process. So I will let you go with that. Let me check to make sure we got everybody on board. As I said earlier, check out the government gold maps. And hello, everyone. Prospector Jess. It's getting kind of crazy. This is summertime. Trying to get all the stuff done I got to get done. And I hope you guys are having a great summer out there finding gold. Keep at it. I've had several of you report in on what you found, including up to 8 ounces recently here. Vic Ta found some really good stuff, and that's what you want to do. You want to find and follow that thing using the techniques I've been showing you, how to isolate and locate where the gold is and then start working it back to its source. That's the kind of fun stuff you can do. And if you're methodical and follow a systematic way of doing it, then you're good. Oh, and I did bring up earlier that we're going to be doing this offer for 4th of July. It's been delayed. Sorry about that. But we will be offering something. So stay tuned for more on this subject. I just have a bunch of processing work to do with my son. We're doing some things to get the thing ready. Okay, so let's see, make sure we got you guys on board. Pages Manager, how are we doing? I just posted a picture of my son's wedding back in June, and on the 15th. That's a World War II Mitchell bomber, a B-25 from the Pacific Arena. They used a lot of these. Pretty cool. That was a Marine Corps bomber. So anyway, I just thought it'd be fun to show that off and get you to comment. So here we are, part 2. Make sure we got you on board, or we'll have to do this all over again. Nope, you're there. So we got everybody. See if we got any questions. Okay, so the sound's coming through fine. Quick nut, LOL. Yep, I'm a quick nut. Victor, could you make gold with pressure? Not so much pressure, but I think I just explained how it's negative pressure that precipitates it out. The key is that the gold is super saturated in these fluids. The hydrothermal fluids are not fluids like you and I think of. It's not like a cup of water. You know, it's think of water mixed with silica or quartz at temperatures that would melt quartz. Okay, now mix in with that some metals. The metals will go into the quartz because the quartz under those conditions becomes acidic, and it will actually ionically sort of work with the metals and take them into solution. So they're floating around. Think of it as the kind of junk that you find in your battery when you have battery acid and it's charged. Okay, so what happens is, if I took this cup of water and I pulled on it hard enough, fast enough, even at room temperature, it would go and flash into what's called steam. Flashing means simply it converts from liquid to gas. Boom. And if it flashes fast enough and hard enough, it can be like a detonation. It can be a big explosion. Well, when that goes, that flashing process also causes what little tiny droplets of fluid are left to have the little tiny ions of gold and other metals. Okay, and so what's going to happen is those things are going to become super saturated. Anytime you have a fluid that's super saturated in something that can crystallize, some element, it's going to essentially start forming crystals right here and now. You can see demonstrations of that on the web, on YouTube, things like that. You know, where you take solutions and you just drop one crystal of salt or one crystal of sugar into these things, and all of a sudden spider webs of crystals. Well, same thing's true here. The minute that thing would flash, or even a part of it would flash, crystals. Once those crystals start to form there, they become a surface for the rest of those ions to find and bond to. And then you get these gorgeous octahedral or cubic kind of structures or mixtures. We've talked about this already in previous shows. Check them out. Look them up. Look up this stuff. And comment below while you're at it. So that's the thing that happens. Good question, Vic. So let's see. Ray Bowen is here. All right, Ray, welcome. And can that flashing be reproduced in the lab? Yes and no. Not at the temperatures and pressures we're talking. We're talking thousands of bars. It's the kind of stuff that forms diamonds. Okay, and yes, you can form diamonds in the lab, but that's pressure. Flashing's a little different, and they have done things like this where they've modeled them they've modeled them on a supercomputer. That's where you would do this kind of work. The problem with most geology at those depths, you know, we're talking 6 miles or more down, is it's pretty hard to simulate in real world experience, because you can't develop those pressures, and certainly can't develop that kind of a pop, that expansion. Remember what I said last night about a 6.5 or so, 6.0, 6.5 earthquake, you know, detonates with the power of a hydrogen bomb, okay? That kind of energy causing pressure and reverse causing expansion, because it has to do both. That's what the pressure wave does, goes in and out, pop, 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 pop. When that happens, that expansion is super fast and super, super strong. So that's why that's needed to do this job. It's not something that, you know, you're going to get by simply forming a fumarole and opening it up at the top. That's the thought. Now, I don't know. There are some thoughts that even in the fumarole sense, these things, especially if they're turning a corner and they're starting to vent out the other side, that they might form gold as well from piezoelectric kinds of effects. My guess is, in reality, there is a mixture of stuff going on here, and that's what makes it so darn complex. And one of the things that makes gold so rare to find, because it really doesn't just, there isn't just gobs of it down there. There's a very trace amount, and it's kind of everywhere. But that trace amount only under the right conditions will form into these nodules and globs we call lode. And then it takes the load and erosion and uplifting from more earthquakes to cause the lode to break down and roll downhill and float. Gold float is a quartz or some kind of ore that is loaded with material that has gold, like this stuff we're looking at on this picture. This is not quartz. This is a metamorphic material with gold in the form of chalcopyrite, so copper, gold, and sulfur. Okay, but there's about a 30% gold, composition in that, so it's pretty rich ore. Okay, so what happens here is when you have that kind of stuff, it's going to roll downhill and break up. If it's metallic enough, it will roll into balls and form nuggets. That's what we see, nuggets, and then the nuggets break up and form all the way to flour. Okay, so, but the idea here is it takes that whole process of the earthquake and the uplifting and the wearing down to get to the nugget. What you want to do is find those nuggets, because they concentrate better than lode does. Find out where they come from, trace that nugget trail back up to the lode, and the float is part of that picture, and then you can kind of put together your own picture of what lode there is. And if you find one of these stringers with that lode in it, or even this kind of ore you're looking at, it can be extremely valuable. Not to mention the fact that it may also be there with other rare earths and things like that that could be even more valuable in today's economy. I posted an article somewhere about rare earths and their connection to kind of the world economy and what's up and coming. There's a lot of interesting stuff happening in the Mojave, out near where this earthquake happened. And what was the original world's largest rare earth mine up until the 80s or so, and then finally shut down in 2002, and has been revived since 2009 because it was shut down because of the economics of rare earth mining and some issues they were running into with regulations and trying to in place, certain kinds of ecological controls. Well, guess what? The whole thing's flipped on its head right now, and they've reopened that mine with new technologies, and they're going to rebuild the whole refinery and everything else, because we have here in the USA, in fact, most of the West, including Japan and Europe, we have no source of rare earths outside of China. So what's happening is, to balance things out, they're bringing back that mine, and there's some investors coming from Japan and other places that already have the refinery capacity for that stuff. But eventually they're going to use a new set of technologies to bring out those rare earths. What I'm getting at is, if you found, while you're prospecting, some rare earths and it turned into an area like that where there's a significant amount of material that has rare earths in it, certain kinds of ores, then it could be very interesting and extremely lucrative in the not too distant future, especially if everybody keeps pushing full tilt on climate zero emissions climate technology, which requires neodymium, specifically magnets, which require a whole package of a certain package of those rare earths to make them. They're strong non-electric magnets, and so unless you're going to use electric power to power the magnets, which decreases your efficiency quite a bit, then you've got to use these magnets, and they're rare, like rare earths. So that's it for tonight. I just thought I'd touch up on that one. Come on, Jess, like you mean it. Let's get this gold. Yes, Ray says. Get that gold. Okay, so I think we're there. Bob Sheasley says he's felt a couple of small quakes in Illinois. There are some along the New Madrid Fault in Missouri. That actually produced one of the most significant quakes in U.S. history, magnitude 8-ish kind of thing, from the kind of collapse of a huge limestone formation back in the 1800s. It was so big that it was felt on the East Coast. significantly. So that's one of those ones where back then there wasn't that much population in that area, but you can imagine between southeast Missouri and the East Coast, there's an awful lot of people. It would be a mess. So yeah, I can see, Bob, if you feel that stuff. And then there's also some stuff, rebound quakes that are happening in the area around the Great Lakes as well. Those happen periodically because of some stuff having to do with the ancient geology of glaciers and the lakes and their formation and stuff, yada yada. So that's it for tonight. Let me let you go and have a good weekend, guys. Good prospecting. I'll see you tomorrow night if you join me. And again, check out Government Gold Maps, sourdoughminer.com/GGM. If you want to learn how to make those gold maps and how to start finding gold near where you live or where you don't. So I will catch you later. Good night and good prospecting. Prospector Jess over and out.